Hello friends, this is your friend Israeli Online Maths. Please, if this is your first time of viewing my video, please kindly subscribe to my YouTube channel at Israeli Maths Concept so that whenever I upload a new video, you will be notified. In this video today, I'm going to show you the derivation of trigonometric ratios of special angle 30 degrees and 60 degrees respectively. How do we go about it? Very simple. Let's begin with the geometry. Assuming we have an equilateral triangle of the form ABC. Of course, one of the properties of an equilateral triangle is that all the three sides are equal. Hence, side AB is 2 units, side AC 2 units, and my side BC is also 2 units. Now, another property of an equilateral triangle is that all the three angles are equal. So, angle A should be 60 degrees, angle B the same 60 degrees, and angle C the same 60 degrees. Alright, the next step or the second step is to divide this angle 60 degrees, which is angle A, into 2 equal parts. And how do we do so? We have to draw a perpendicular from the point A and it hits the base BC at a point D. Now, because we've drawn a perpendicular part or side which divided this angle A, which is 60 degrees, into 2 equal parts, this angle A is now 30 degrees respectively. 30 degrees, because this perpendicular line have divided it into 2 equal parts, and we have 30 degrees respectively. The next thing we are going to do is very simple. We want to know what BD is. So BD, side BD now is 1 unit, while side CD is also 1 unit. Because this perpendicular line AD divided the base BC into 2 equal parts, it now splitted these 2 units into 2 equal parts, which is 1 unit and 1 unit respectively. Now I'm concerned with triangle ABD. So I now say from triangle ABD. Now I want to know side AD. I've known that side AB is 2 units. And I've also known that side BD is also 1 unit. But I don't know the side AD. What is it? So one of the things that will help me to know my side AD is to use Pythagoras Theory. And Pythagoras Theory states that the square of the hypotenuse side of a right angled triangle is equal to the sum of the opposite side plus adjacent side of the triangle. Now, I'm concerned with how I can be able to find my side AD. Now, the hypotenuse side is the longest side of this triangle ABD, which is side 2 units. So I now put 2 units and I now put my square, which is equal to my opposite side. And my opposite side, I'm considering angle 30. Hence, my opposite is where 30 is facing, which is BD. And that is 1 unit. 1. I now put my square. Plus my adjacent side is 2 units, and where is my adjacent side? Side AD, which is the remaining part of the triangle, and I don't know what is it. I can just call it X, so I call it X squared. Now 2 squared is 2 times 2, which is 4, which is equal to 1 squared is still 1 plus X squared. The next thing I'm going to do is very simple. I make my X the subject of the formula. Hence, my X squared is equal to 4 minus 1. And my X squared is equal to 4 minus 1 is 3. Now, I want to know what my X is. I find the square root of both sides of the equation. The square root of both sides of the equation. So that this square will now cancel out the square root, leaving me out with X. So my X is equal to square root of 3. So this my X, I'm removing X to replace it with square root of 3. In other words, sod 3. Now I've succeeded in finding my side AD. The next thing I'm looking towards is how do I derive the trigonometric ratios of special angle 30 degree and 60 degree. It is very, very simple. There is a formula or trick that will enable you find it with an ease. Now, what is that formula? I call it SOHCAHTOA. SOHCAHTOA. Of course, the S means your sine, and your sine is equal to the opposite over hypotenuse, and your C means your cosine, and your cosine is equal to adjacent over hypotenuse, and your T means your tangent, which has the trigonometric ratio of opposite over adjacent respectively. But I'm concerned for this very angle 30 degree. After deriving the trigonometric ratio of angle 30 degree, I'm going to also derive that of 60 degree. So let's begin by 30 degree. Now I begin with sine theta. Sine theta is equal to opposite over hypotenuse. And this is my opposite all over my hypotenuse. But because I'm talking about the angle 30, so my theta will now change to sine 30. My theta is now changing to 30 because I'm considering the angle 30 degree from this triangle ABD. So sine 30 degrees is equal to opposite over hypotenuse. And the opposite is where this angle 30 is facing directly, which is side BD. And that is 1 unit. So I have 1 unit all over. My hypotenuse is the longest side of this triangle, which is 2 units. So it becomes 1 over 2. Hence, the trigonometric ratio of sine 30 is very simple, 1 over 2, which is the same thing or congruent to half. Now, let me check for my cos 30 degree. My cos 30, cos is equal to adjacent over hypotenuse. And what is my adjacent here? That is side AD, which is square root of 3. So I now have my square root of 3 all over my hypotenuse, which is the longest side of the triangle AB, which is 2 units. So I have square root of 3 over 2. Hence, the trigonometric ratio of cos 30 degrees is equal to square root of 3, all over 2. Then I also have for my tan 30 degree. My tan 30 degree is equal to opposite over adjacent. And my opposite is 1, which is where this angle 30 is facing directly, which is side BD. And that is 1 unit. I write 1 all over my adjacent. My adjacent is apart from this opposite and this hypotenuse. The remaining side of this right angle triangle ABD is side AD, which is my adjacent. So my adjacent is square root of 3. So I now write square root of 3. Now this square root of 3, I need to rationalize it. I multiply both the numerator and the denominator of this 1 over square root of 3 by square root of 3 over square root of 3. Now, 1 times square root of 3 remains square root of 3. All over. Square root of 3 times square root of 3 is square root of 9. This is equal to square root of 3 all over. Square root of 9, of course, we know is 3. So the trigonometric ratio of tan 30 is equal to square root of 3 all over 3. Now let's do the last thing. And that is for trigonometric ratio of 60 degree. Now let's begin with sine theta equal to opposite over hypotenuse. Now I'm considering 60 degree now. So this is my 60 degree in this triangle ABD. So sine 60 degree is equal to, I now put 60 degree here, is equal to opposite over hypotenuse. And my opposite is where this 60 degrees facing directly, which is side AD. And that is square root of 3. So I now have my square root of 3 all over. My hypotenuse is the longest side of this triangle, which is 2 units. Hence, sine 60 degree is equal to square root of 3 all over 2. Let me also take for that of cos 60. Cos 60 is equal to, cos is equal to adjacent over hypotenuse. And adjacent, apart from this opposite, the adjacent is side BD, which is 1 unit. So I have 1 unit all over. My hypotenuse is the longest side of the triangle, which is 2. So the trigonometric ratio of cos 60 degree is equal to 1 over 2, which is the same thing as half. But there is something very unique. You can see that sine 30 degrees is equal to 1 over 2. That is the trigonometric ratio of 30 degrees, and that of 60 degrees, the same thing as 1 over 2. Hence, they are equal. Now, let me also take for tan 60 degree. Tangent is equal to opposite over adjacent. And now I have my opposite here, which is square root of 3, all over my adjacent. This is my opposite, and this is my adjacent, which is side BD, which is 1 unit. This is 1 unit. And square root of 3 over 1 is the same thing as square root of 3. Alright, we've succeeded in deriving the trigonometric ratio of special angle 30 degrees and 60 degrees respectively. Please, if you consider this video very useful, kindly just comment on my comment section. Also subscribe to my channel at Israeli Maths Concept so that whenever I upload a new video, you will be notified. Try to also share to your friends and family. See you next time as we grow together in mathematics. Thank you.